We are going to go over some basic laws that are always true when translating. Okay, we practiced translating shapes under lesson 2. Today we are going to learn the laws when translating lines. So by the end of this lesson, you will know that when lines are translated, they are either parallel to the given line or the lines coincide. What does coincide mean again? It was our vocabulary word last time we met. Coincide. Okay, well let's take a look at a translating line. If I draw a line, okay, if I translate this line, translating again means only a slide, right?
Yep.
Okay, what is always going to be true as I translate this line?
It's going to have the same size, same shape.
Same shape.
Okay, what's true about these two lines though, no matter what?
They're parallel.
They're always going to be parallel. When you translate a line, they are always going to be parallel. The only other choice of not being parallel is if I have two lines and it translates directly to the left or to the right, what's going to be true about those two lines? It makes what? Just one line. Those are two lines that coincide. Okay? Meaning it's one line. So your two choices when translating a line is you either create two lines that are parallel, or you create two lines that what is called coincide. Vocabulary word of the day. They create one line together. That is what we are going to prove today in lesson 3. So we're going to start in lesson 3. Under number 1, we're going to press pause when we go. Okay, everybody should have a line that looks like this, yes?
Yep.
The challenge then is to draw a second line, not this one, passing through point P that is parallel to line L and that is distinct, meaning different from the first one. I'm going to give you 3 seconds to do this. Go. Okay, so all of you are saying you can't do it. Why not?
I'm doing it right now.
Because it can't. Because when you translate it, it needs to be the same size.
Okay, so here's the lesson. You can draw one and only one line to go through a point that is parallel to a line. Okay? Any line parallel to a line going through a point will create one and only one line. All right, the other thing I want to point out, anytime you have to translate a line and you need it to be exactly parallel to this line, what can you create that will make a perfectly parallel line to the existing line? It requires 2 things. 2 points. If I create 2 points that have an exact same distance away from an existing line, if this is a straight line, 2 points will always create how many different lines? 2 points will create 3. Won't it just create one line if you connect those 2 points? Yeah. Is there any way a different line can be created by connecting a straight line between any 2 points?
No.
No. Anytime you're translating a line, Mr. Newbarth, it takes 2 points, and then forever and ever, the 2 lines will be parallel to one another. Okay. All right, let's go on to example number 2. So what we learned in example number 1 is that how many lines can you create to be parallel and going through a point? 1. Number 2, you are going to translate this line along this vector. On your mark, get set, go. Okay? So if I take this line right here, I'm going to translate it along the vector. My line, I measured it first hour. It's 4 centimeters long. So I take that line and I slide it 4 centimeters in the direction of my vector. What do I notice about my first line and my image line? They coincide. Remember, as we're translating these lines, how many different options of what these lines can do? There's only 2. They're either going to be parallel or they're going to coincide. So in the first one, when I'm putting it along a point, I created parallel lines. When the vector is heading in the exact same direction as the existing line, the 2 lines coincide. Just a minute, lady. Okay, quick, go get it because she's on video. Making me look like a crazy woman. All right. Now, line L is parallel to this vector. Okay, here we had a vector that existed on line L. So here we're going to look at a new example where line L is parallel to the vector. And you are going to translate line L along the vector. On your mark, get set, go. Okay, so now we have a vector that's parallel to our existing line, meaning that we are going to slide the existing line directly to the right, 5.5 centimeters for me. And what kind of line do I get? The 2
Coincide.
lines coincide. They create the same line. Final one. Now, here is our line. We have a vector that is perpendicular to our existing line. What does perpendicular mean?
Up.
Exact same.
It is a degree marking. Very good. 2 perpendicular lines create a 90-degree angle to one another. So our vector is perpendicular to our existing line, and we are going to translate this line along this vector. What kind of line do you get? On your mark, set, go.
Go.
Okay, the key to remember as we're translating, translation, remember, is having an existing figure and then sliding it into a new location. So with the smartboard technology, I can trace my existing image and I can slide it around. So this line, I can slide straight up to the top of my vector. And what kind of a line does it create with the original?
Parallel.
They create parallel lines this time. Remember, if you have a straight line and you slide it, it's going to be the same distance away from the original line because you slid it equally all the way across the line. That's what a translation is. Okay? So, anytime we translate a line, the only 2 possibilities are what kind of lines? Parallel and coinciding, and I think that we've proved that. All right. Now, line L has been translated along vector AB. We're on example number 5. Resulting in the image. So now they've done the translation for us. Here's our original. Here is the vector. Here's the image. What do you know about the 2 lines?
Parallel.
They're parallel. Anybody have questions about that? We just did it on the previous page. Now we've seen it again. Here, oh, and I have them here. Hang on a minute while I delete some things. Sorry. Under number 6, okay, we are going to translate line 1 and line 2 along this vector. Okay, so here's your vector. Here's the length of your vector. This is the direction in which you're going to slide these 2 lines. If line 1 and line 2 are parallel, so they're telling you right now that this line and this line for surely are parallel. What do you know about their translated images? Okay, so what you're going to do is, first of all, you are going to translate line 1. What did I say is the best way to translate a line? By creating how many points? 2 points and then connecting them. So let's see what that looks like. On line 1, I'm going to create a point here. I'm going to create a point here. When I translate my lines according to my technology, it's going to move 5.5 centimeters at this angle. So I come down to my first point, and I put a mark at 5.5 centimeters. So this point translates to right there. Come over here, and this point is going to translate to right there. Okay, it's a little off, sorry. All right. Now that I have 2 points, I can create what? A straight line. Because remember, 2 points create one and only one line that's going to connect them. Now I've translated line 1. I'm going to go do line 2, create 2 points. I can create them anywhere on my line. I'm going to translate the 2 lines. Exact same vector, so it's still 5.5 centimeters. I'm going to take a line and connect those 2 points. Just fix my line because it's taking a little off. Okay. Now, if we think about what we knew, what has to be true about this line and this line? This line and its image. These 2 lines have to be parallel. Okay? What has to be true about this line and its image? They have to be parallel. What do we know about the 2 original lines? They were parallel. What has to be true then about my 2 image lines?
Parallel.
They have to be parallel. If you start with 2 parallel lines, and you create an image for each, all of these lines are parallel to one another. Are there any questions? Okay, go ahead and hit stop.